Dark Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. My name is Omer, and I'll be co-hosting this show together with Queenie. Today, we are thrilled to be joined by Mo Dong, co-founder and CEO of Brevis, an efficient, verifiable off-chain computation engine powered by zero-knowledge proofs. Mo, it's great to have you on the show.
It's great to be here. Thank you, Omar, and thank you, Queenie. It's amazing to be talking to some of the brilliant minds in the ZK space.
So Brevis is one of the strongest teams out there, consistently delivering for years now. Hopefully, in this podcast, we can learn more about the secret to your success. Now, first thing first, can we start by a brief introduction about yourself and Brevis?
Yeah, sure, certainly. So, hi everyone. This is Michael from Brevis, and you know, I've been in the Web3 and blockchain space for quite long. Now, counting towards 7 years. Previously, I'm co-founder and the CEO of Saturn Network, and then even before that, I co-founded a networking security company and sold off to VMware. And before that, I did my PhD in computer science, in UIUC. Brevis, has been around for almost 2 years now, and yeah. So this is like what we have been building. We're super excited about the future of ZK beyond the initial application of things like ZK rollup, and that's why we're kind of building Brevis, and very excited to be here and share not only just the technical side of things, but also about the adoption, go-to-market, and the applications that we see. Um,
Michael, so actually we got to know each other since 2018 when you were still building Stellar
yeah.
network. So from a bridging protocol to a ZK coprocessor and now to a ZKVM, I'm curious, how did these dots naturally connect?
Yeah, so if you remember, Queenie, when we first met, I was very much into this concept of off-chain computing in the off-chain scaling. So back then, before there was this concept of rollup or even plasma, there was the concept of state channel, and the concept of the state channel is to migrate a certain kind of computation that is very hard to do on chain for especially real-time use cases. And then you do the computation off-chain, but having kind of a cryptographically signed signature among all the involved parties about the actual state of the computation, and then settle it back to the blockchain later on. So it is kind of a generalized version of the Lightning Network in Bitcoin, and this is something I have been always super enthusiastic about, because I do believe that fundamentally speaking, if we look at blockchain, even with layer 2 scaling, it is still a replicated computing and replicated storage with huge networking overhead, computation system, right? So this kind of a computation system have fundamental limits in terms of the kind of scalability it can achieve. And, therefore, I have been always very interested and, enthusiastic about offloading any kind of computation from on-chain or to off-chain, right? So, I think if we look at the entire blockchain scaling, evolution in history, this is has been the recurring theme, from a high level, right? So if we look at the rollups and specifically ZK rollup, it is one instance of doing such kind of off-chain offloading, right? So you can kind of essentially offload the EVM execution, very specific EVM execution, to an off-chain environment and send it back to the layer 1 blockchain via ZK proof, and use these ZK proof as a method to do cross-chain bridging between layer 1 and layer 2, right? So that's the but we think there are many more things you can do, using kind of a ZK as a technology to use the same concept of off-chain, verifiable computing. So yeah, that's how the dots are connected.
So it sounds like a very natural evolvement. So, and it also reminds me of some ongoing discussions about using ZK to achieve interoperability. So, given your background in building cross-chain infrastructure, I'm curious about your perspective. Is this both achievable and ideal, and is it a potential path that you guys will pursue in the future?
Yeah, ZK interoperability is interesting, right? So like, there are various different kind of interoperability solutions out there. Celery is based on State Guardian Network, which is a proof of stake system, right? But we have also been looking at like ZK-based ZK bridges essentially, right? So the concept of ZK bridge is that you can essentially run a ZK client, ZK consensus client, to generate proof of one chain reaching consensus and verify that proof on a different chain. Once you can verify that proof on a different chain, you can essentially have the high level of confidence that anything happen on that chain is actually finalized. And because like you're essentially validating the consensus of one chain using another chain, through ZK proofs. The concept of ZK interoperability is beautiful, but in practice there are a bunch of challenges, right? So first of all, it is not very scalable to build. Because like for different kind of a ZK, for different kind of consensus protocols, they basically need to write a new set of ZK circuit if you're just using the low-level development frameworks. And that is like highly unscalable, because like kind of a different consensus algorithms may have very, very different characteristics and may use different signature schemes, may use different kind of randomness schemes, and so on and so forth. Right, so building that is itself is pretty hard. So that's kind of like one challenge. Another challenge really comes with cost. So to build, ZK consensus client or consensus kind of a light client, for that matter, you basically need to essentially have a long history of validated blocks. So it's not only it's not sufficient to just have one block, on demand one block, validated and verified, right? So you basically need to kind of verify the entire blockchain history. And for many consensus protocols, there are some consensus protocols that is kind of independent, block independent, but for most of the consensus protocols, you actually need to do that. So to do that, like if you don't actually have cross-chain messages to be sent on every block, that cost accumulates pretty fast, right? So like that's why from kind of a usage perspective, actual end user using ZK-based bridges perspective, the cost is also going to be pretty high. There are ways you can reduce that by essentially group and batching different kind of block headers and verify that in a batch in a recursion proof on a destination chain. But that comes like with the trade-off of latency versus cost, right? So overall, we just don't see for many of the cases, we don't see there's like a very strong fit right now for ZK-based interoperability solution, because there are many other solutions that are operating stably and with extremely low cost. So yeah, that's our take on that. But I think with ZKVM, the cost of building ZK-based interoperability will drastically reduce. And that might be a good time to revisit this entire space when we have kind of a more flexible underlying architecture to build things.
Would you like to extend on this point a little bit?
Yeah, sure. I think the thing is that for example, if you want to write a consensus algorithm for Avalanche, let's say, it uses this kind of a consensus algorithm where you have multiple different branches, and then you kind of randomly choose one branch and go forward. So these kind of consensus algorithms, if you want to write it directly in ZK circuit, is actually pretty painful to implement. But if you look at Avalanche, it itself has Rust-based a protocol client. So if you have like a ZK VM that is supporting Rust, for example, you can just like directly use the same code and have a ZK proof of the consensus being achieved directly out of that Rust-based implementation. You don't actually have to write anything. Of course, the performance of using a ZK VM directly in that sense, versus like just using specialized ZK circuit is going to be very different. But this is like what we have been pushing for, right? So like, we can probably kind of reduce and identify what are the bottlenecks in certain specific application use cases and use a glue and a coprocessor architecture to optimize that.
That's super helpful. So then let's talk about the product you're
Yeah.
building now. So what is Pico?
Yeah, well, so Pico is not actually the first product for Brevis, right? So like, Pico is our ZKVM, and I'm very happy to talk about that soon. But the first product we built is called Brevis ZK Data Coprocessor. The reason I want to kind of talk about that as well is that it will help us to hopefully the audience to understand where we came from, right? So like and how our approach might be different in terms of go-to-market and application adoption, right? So really we started to look at we all know that ZK is very helpful in offloading certain kind of computation from on-chain to off-chain, but you're not just like doing only the computation off-chain, right? So you're doing the computation itself, but also generate a ZK proof to bring it back to the blockchain. So the blockchain can very easily verify the proof with almost constant cost, and then kind of consume the result directly in the smart contract, right? So like the first kind of a computation that we want to tackle is actually something related to on-chain historical data access and computation, right? So like I can give you a very, very concrete and motivating example for this, right? So like if you look at every centralized exchange, be that Binance, OKX, Coinbase, they all have this kind of a market maker fee rebate program or fee discount program, where if you are a market maker or a big trader that traded a lot in this month, like let's say in March, in April you will get like a percentage, a percentage in discount in trading fees. This has been proven like it is like really battle tested, proven feature that can help to retain large traders and also provide better market structure because you can have market makers to have like less spread to merge and cross exchanges because they have lower trading fees, right? So it in the end it boosts the bottom line, the revenue for these exchanges. But if you look at decentralized exchanges, like be that Uniswap, PancakeSwap, anyone, none of them have this kind of a feature. Like even if you traded like $100 million per month, you're being treated at the same as like someone traded like $10 per month. So the reason that this kind of thing doesn't really exist is because of a simple limitation for smart contract, right? So smart contract today doesn't have the capability to access historical user behavior or historical states. So for some of the more technical audience, you might think, oh no, that's not right? Because like, on blockchain, you have access to block header. So in theory, you can actually access anything from the block header. Well, you're right, but that kind of computation of accessing and figuring out what is a user behavior through in the past through a block header is basically doing a huge amount of Merkle proof, Merkle inclusion proof. This kind of computation on smart contract is insanely expensive to the point that is entirely impractical. So but we see there's a very strong market fit here. Like many of the DEXs like Uniswap, PancakeSwap, they're moving towards what they call like a plug-in based or modular architecture, where you can change the behavior of swap on the fly, dynamically changing fees, dynamically changing the amount of tokens that are being swapped, and so on and so forth, right? So this is where you actually can use a lot of historical insights of a user, of the market, to change and provide a better user experience, better market structure, and in the end, better revenue for the DEX, right? So like this is why we, where our ZK coprocessor really shines, in the sense that you can essentially generate things like trading volume proof of a certain user, and then that user can essentially use that proof to trigger a fee discount or trigger dynamic fee indexes, so that they can enjoy lower fees and retain the DEX better, and trade more, and provide a better market structure on chain, right? So that's kind of like one motivating example of why we started in the ZK journey, really like off-chain verifiable computing. And then but there are more than just like dynamic DeFi or intelligent DeFi, right? So like one of our flagship partner is Euromoney, which is like a rising star in the stable token ecosystem, right? So we power their entire token distribution program. 60% of all euro circulating supply will be distributed by Brevis powered solutions. So how this works is that instead of just like doing centralized airdrops, users of Euro and USD0, which is like the stable token, can now generate proof, ZK proof of their interaction, of their liquidity provisioning, of their swap usage, of their staking, whatever you want. You don't need to write any smart contract for that. You just like write a Brevis powered application business logic to essentially allow users to generate their contribution level to the entire Euro ecosystem, and they can use that proof to essentially claim reward or claim a evergreen airdrop or claim evergreen continuous protocol incentivization using that, right? So that's kind of like opens up the space you can do with this kind of a historical on-chain data proof, and so like but then going into the VM side of things, so if you look at the entire off-chain verifiable computing space, right? So this is kind of a the VM and the ZK coprocessor are starting from two different places. VMs start with like high programmability, but very relatively low performance. And for us, we started from like a high performance, extremely high performance. We can handle like millions of transaction events in single proof. But relatively low programmability. It's you don't need to write a ZK circuit anymore, but you still need to write a bunch of like a specialized API to do data stream based processing, and it's very much data oriented. That. So, but I think the entire ZK off-chain verifiable computing space is going to gradually move towards a common goal, right? So where you have a continuous spectrum or continuous optimal line. It's basically a Pareto optimal line of programmability and also like performance, where you can essentially express a lot more flexible business logics, but at the same time have like a very strong performance. So like this is one of the motivations that we introduced Pico, which is to allow developers to essentially have this kind of a high performance in data access and data attestation. But also at the same time, once they get the data, they can just write a bunch of raster programs on top of this data to operate and to compute, to kind of manipulate however they want, right? So like that's kind of like the motivation for us to entering in this ZK VM space. But we did a lot of kind of interesting optimization on that end. I will pause here and see if there's any questions we can talk about.
So you actually combine ZK coprocessor with the ZKVM, or you integrate them together?
Yes, that's right. That's what we did, right? So like I think if you look at all the ZK VMs today on the market, every single one of them is built using this kind of a glue and coprocessor architecture. So the glue itself is the RISC-V ISA, the instruction set itself, like everyone's kind of a standard. But no one is actually a RISC-V ZK VM, because every ZK VM comes with some specialized things to accelerate certain kind of operation, and we basically use this kind of RISC-V ISA as a glue, and then kind of have a bunch of like specialized coprocessors. I'm overloading terms here, unfortunately, but this is a kind of a thing that Vitalik mentioned as well. These kind of coprocessor to specialized coprocessor to accelerate certain things, right? So, however, if you look at all the existing VM other than Pico, all of them are only just like targeting low-level pre-compiled coprocessors, like things like hashes, some part of curve operations, and so on and so forth. So, what we are, championing here is a new kind of architecture where we focus a lot on the app-level coprocessor, where you can put a large chunk of, business logic or your application logic not only in specialized circuits, but actually in a specialized system, right? So like our ZK coprocessor itself is a highly parallel and the GPU accelerated system, thanks to Ingoyama, support on that for sure, right? So so that kind of architecture is where we see the ZK VMs are going, right? So like different ZK VMs start with maybe the same kind of a core RISC-V architecture, RISC-V kind of a glue, but because the go-to-market strategy of different kind of a VM team might be different, you will see kind of the VMs start to diverge and non-standard things start to emerge, right? So some of them will purely focus on pre-compiles, but for us, we're not only just a pre-compile, but also having this kind of app-level coprocessor. You can put a lot more logic in and accelerate, things in a tremendous way, right? So like, for example, like, if, using this kind of app-level coprocessor, just comparing with vanilla Pico, which is already highly performant on GPU compared to all the other VMs, there is additional benefit of like, there are 30 times more performance that you can gain via this kind of app-level coprocessor architecture, right? So that's the benefit that we see from kind of our modular architecture. But there are a lot more to it than just like app-level coprocessor as well.
Yeah, I actually think that some of the ZKVMs out there do not really have a go-to-market. So it's good to know that you are driven by GTM. What's the origin of the name? Just curious, like why Pico?
Oh yeah, this is like great question. It's like Pico. I think like we tend to name things like with similar method. Like Brevis is I think Latin for succinct, and Pico is like I think has the kind of the root meaning of like fast basically. So like fast and nifty kind of quick. So that's kind of like the reason for the meaning for the naming.
Okay, so fast is one way to describe the ZKVM. There are certain design choices that we've noticed. You support multiple fields. Maybe you can share more about like some of these design choices and where they came from.
Yeah, certainly. So I think one we so for Pico, right? So like we built Pico with two goals in mind. One is fast and performant, and the second is actually modular and future-proof. So on the modular side, like you mentioned, we support different kind of proving backend and different kind of things. So there's a motivation behind those, right? So like different kind of dApps features often requires the most advanced proving system on certain kind of a prime field, right? So like the reason we want to have a flexible proving backend is because we have seen the ZK space and the ZK research and engineering space has evolved so much in the last 2 years that like if we go back to 2 years from now, like I don't even recognize many of the things that I wouldn't believe many of the things we can do today like back then, right? So but to make our ZKVM truly future-proof, we want to make the proving backend something that is like flexible and modular. So for Pico, it's the world first ZKVM that support multiple prime fields, including Baby Bear, Cola Bear, and M31. And we also support like various different kind of approving system like Stark and Circle Stark, which is like the M31 on Circle Stark. And the reason there's like also real world benefit of this, right? So like a very illustrative example of this is the process to prove a very widely used recursion friendly hash function called Poseidon 2. So Poseidon 2 is extensively used in recursive provings in ZKVM. Now, even with the same kind of Stark, which a lot of other solutions based on Baby Bear, we proving this kind of proving this Poseidon 2 function on Cola Bear field is actually much more efficient than Baby Bear due to the field's like unique property. I won't go into too much of the technical details. So like we can see that when a program itself also maybe incur a lot of Poseidon 2 proving, a considerable performance gain will be achieved by simply switching the configuration from Cola Bear to switching the configuration to Cola Bear without actually touching the proving logic. And switching kind of these kind of proving backend configuration is very, very simple. in Brevis. It's really just like kind of a configuration file. And so I do believe that in the future we will still see more evolution in prime fields, improving backend systems, and this is something that we can definitely quickly adapt and quickly incorporate in Pico, comparing to kind of the non-modular architecture. And another thing about like Pico in terms of modularity is our capability to customize proving workflow. Right, so there are several kind of layers to this. The first is that you can customize the instance of the VM. Basically, in the VM, you can customize like what kind of a chip you actually want to include in your VM. If you don't want to kind of include certain kind of operation or specialized for your specialized application, you can just like take that out without actually incurring the fixed cost for some of the chips incorporated in the baseline VM. Also like you can actually change like what kind of a proving process you want to balance speed, memory usage, and proof size itself. So like that's not all of these things are tunable in Pico's configuration settings. And then you can also like even change the entire proving workflow, right? So like right now, the default workflow is that we basically kind of first chunk the RISC-V program into multiple chunks and prove these small chunks and then convert them into a recursion proof. The recursion proof are combined into a single recursion proof. And then we compress them and embed them into a BN254 field for on-chain verification. But if you don't want to actually have that on-chain verifiability, you don't actually need to have the final on-chain embedding on-chain step. And you can actually gain some performance by tweaking how you want to lay out and pipeline the entire proof generation process. And this is, I think, going to be very important for many of the applications that we see. They're just not very uniform, but like very different kind of application intelligence, intelligent DeFi use cases, token distribution use cases, and many of the infrastructure use cases as well. So yeah, that's kind of like the thing that we're pretty proud of. And on the performance side, we're really now setting the new state-of-art performance on CPU. So we don't have a GPU implementation out yet, but like we're hoping to collaborate with some of the great teams in the space to push that forward. And we have been a very happy user for Icicle from Ingoyama as well. So hopefully we can see some pretty good result with that.
I would also add that Pico is it's a good educational resource. Like it's fully open source, and we learned a lot from reviewing the code in general on ZKVM design space. Is there any goal here that to accept contributions from the community, or in other words, where you guys are in terms of the roadmap, other than working on acceleration and performance? Are there other areas that might be interesting for contributors to look into?
Yeah, definitely. So I think there are a lot of interesting things we're looking at, and some of the community is already kind of talking about this in our chat groups and Discord as well. For example, right? So like there are still a lot of things that you can do on a proving system and entire proving flow side. Ranging from things like if we can use GKR for many kind of common operations in this. So that's kind of a new essentially. Well, I guess to back up a little bit, right? So like I think there are two general directions of contribution. One is that I like to kind of further enhance the coprocessor side of the glue and the coprocessor architecture, right? So like that include to use new kind of proving systems to tap or kind of integrate some new things like GKR based catch-up, for example, is something that we have seen that is very, very promising. and we'll probably incorporate that very soon. And the other is like to kind of more on the underlying improving system side of things, and see if there are any other things that you want to try out on Pico, because like we have a modular and very flexible backend, you can swap things around without actually rewriting the entire stack. And finally, for application use cases, right? So like if application developers have a certain kind of a use cases, and after profiling and after benchmarking, we see there are certain bottlenecks or certain things that we can take out from the existing VM or proving flow, that we can actually have specialized versions forked and created for that. So yeah, there are many paths to contribution that we welcome out of that. Like we're already seeing a bunch of like a community contribution, especially on the GKR side of things, which is like a very exciting and getting some very, very interesting performance gains.
I want to talk about ZK benchmarking.
Yep.
So Brevis are known for Pantheon, right? You had this effort, ongoing effort to benchmark ZK provers. And now I've seen that you're also taking a similar effort with ZKVMs. Can you describe more this effort, and what's the motivation? What are the challenges in benchmarking ZK, and maybe some insights you got so far?
Yeah, for sure. So I think we did the pantheon of ZK work when we first started to look into the ZK field. That was like roughly, I think like roughly 2 years ago, from today, and we so the reason we wanted to kind of to do the benchmark really was because that we want to know that what are the frameworks that is available on what were the frameworks available on the market, and what were the developer experience, and what was the performance, right? So like just any kind of a ZK developer wants to build something, the first question to answer are those. And we did these kind of exercise ourselves, and we don't want to just like hoard this kind of discovery and findings ourselves, but I want to share with the community, right? So like there's no that's kind of like our pretty straightforward motivation for this. So it's just we did this for our own sake, and we want to share it with the community. And but I think that really kind of helped a lot of folks to look at this space in new lenses, right? So like back in the days, like 2 years ago, everyone was still kind of using some things like Halo 2 as a default development solution. But what we discovered was that Halo 2 itself doesn't actually have kind of a native GPU acceleration framework, and also have like a kind of a pretty steep curve in terms of a learning curve. And then we start to realize like Gnark is like a great solution, super developer friendly. This is like how we built our first version of the ZK coprocessor, right? But then during the benchmarking process, we also looked at Plonky 2 a lot, and realized that Plonky 2 and Stark in general definitely entails like a significant performance gains, and this is like why we kind of switched to many of the kind of things to Plonky 2 for the second version of our ZK coprocessor, right? So I think that's kind of like, but benchmarking ZK low-level ZK development frameworks are relatively easy, because you can have very accurate benchmarks for low-level functions and construct that you care about, right? So like you can benchmark hash functions, you benchmark certain kind of operations, and be done with it. But benchmarking ZKVM is like a whole different thing. We were thinking about kind of really doing a good benchmark work, very comprehensive benchmark work for ZKVM, but it turns out that you cannot really kind of use simple things like Kachak, signature verification to benchmark ZKVM, because then you're essentially just not really benchmarking the ZKVM itself. You're just benchmarking a very small subset of the precompiles, right? So like now to get a very, very comprehensive benchmark for different ZKVM, you need to have a diverse enough program, large enough program that like exercise sufficient amount of muscles for the different ZKVM, right? So I think right now community is trying to come up with certain kind of cases like that, right? So one example is Queenie, you guys have been kind of championing for the ETH-proof, which is trying to prove the Ethereum block execution. This is a great example, right? So like in many of the applications, not only like this is good not only because it can enable things down the road for native rollups and things like that, but many of the Ethereum-based application use cases, like even for the intelligent DeFi and so on and so forth, many of the operations involved is similar to the operations involved in executing, the Ethereum block in a ZK EVM setting, right? So I think that's a great example. And what we feel that there can be other good examples are, I mean, for ZKVMs, all the benchmark examples or benchmark tests should come from real world use cases. That's our stance, right? So therefore, for things like intelligent DeFi, ZK coprocessor use cases, token distribution use cases for user to prove their contribution, and pre-confirmation use cases to prove like kind of committed blocks is committed to transaction is actually included, and so on and so forth. These kind of use cases are something we want to see in the future benchmark set. And I think we're in the very beginning of building a ImageNet equivalent of ZKVM, right? So like ImageNet is like a kind of a standard benchmark for many of the AI frameworks, like for image recognition, for CV type of things. But we need to have that, a very diverse and very strong and real-world driven benchmark set for ZKVMs as well. And we are very much happy to kind of contribute to that.
I'd love to learn more about the current competitive landscape. So, Michael, how do you see the competition among ZKVMs evolving over the next few quarters or years? And what market are you competing in actually?
Yeah, I mean these are great questions, right? So like I think so for us, right? So like we entered the market very differently. Like if you look at many of the ZKVM teams out there, they are very much focused on infrastructure level use cases, like essentially kind of turning EVM blocks into ZK verified execution. That's kind of like one of the biggest like use cases out there right now. But we're coming into this kind of a space a bit different in the sense that we were we kind of started to work on this because our partners and customers demands it, and so like for example, like our partners are very different from like kind of other ZKVM solutions. Like we partner with PancakeSwap to power their upcoming V4 DAX, the entire kind of many of the V4 user flow and user experiences are actually going to be powered by Brevis. And we work with like a DeFi, we work with not only them but like QuickSwap, Sina, Baraboro, Gamma, all of these kind of DeFi and user-facing applications are really our target. And this is something that we have a how should I say, like a advantage too, because like we have the ZK data coprocessor available that is like insanely fast and highly scalable, that none of the existing VM, even just like vanilla Pico, can beat that performance and can actually undertake that kind of a large scale use cases. So that's kind of like where we see ourselves are. And I do believe that and one of the reasons I'm still kind of very enthusiastic about crypto after 7 years is still like I see there are product market fit, right? So like after we kind of together working in the space for 3-4 years, we see DeFi, and I really do believe that from kind of a user facing perspective, we're just like scratching the surface of user experience and how many of the DeFi and user facing application can be built and should be built. And I do think off-chain verifiable computing is going to play a huge role on the user-facing side of things, and that's where we're targeting, right? So that's where we are targeting, and we're not initially kind of a super focused on the high-level infrastructure cases. So I think that's good because we different VM team have different focuses, and I don't see many others have our focus like ours. So that's kind of a uniqueness that I would highlight and point out. But I think just in general, for different ZK VMs, the RISC-V part of this won't matter much. Given 1 year, 2 year, everyone's gonna have like a GPU acceleration one way or another. Everyone's gonna have a highly optimized parallel system one way or another. We all have the resources like a huge funding behind each of the team. So what's actually gonna matter is the non-standard part of this. The non-standard part can be something, like seemingly superficial, like developer tooling. How do you run Docker to spin up this ZK VM? How do you connect to the prover network for this ZK VM? How do you kind of offload resources? How do you do compilation? These kind of small things will actually bind, user into different VM solutions. But these things, I myself think that these things are not strong enough. Given enough motivation, people are still gonna actually switch from one VM to another, right? So people have been talking about, oh yeah, like ZK VMs are gonna be commoditized in 2 years. What's the purpose of building like 10 different ZK VMs? Well, I think the divergence is gonna be more than actually just like the developer tooling and superficial type of things, because the the adoption vertical or the go-to-market for different team might be different. You will see different VMs kind of grow into that go-to-market vertical, right? So that kind of non-standard things, like for example, for us, it's a ZK data coprocessor. For different VMs, it might be different things. For people focusing on EVM, you might actually end up with something like a specialized ZK EVM versus like a generalized ZK VM somewhere in between, right? So you can have a large chunk of the EVM logic running in this kind of app level coprocessors. I totally see that, right? So every ZK VM will grow, in different kind of development and adoption verticals, and once that kind of a growth is established, the partners in that sector is going to be attached to that VM, very much, right? So I think right now, the every ZK VM and similarly to all the other kind of similar infrastructure projects is what is the go-to-market that everyone's betting on, right? So whether the go-to-market direction is actually correct or not. So that's no one knows, I would say, at this point, and we're also making bets. So as many of the other ZK VM teams, but yeah, that's the choices we have made.
That's exciting to hear. So I guess maybe one of the keys to success is to get as closer as possible to the demand side. So would you also like to touch upon on the ZKML solution you're building?
Oh yes, forgot that. So verifiable inference is something that I'm also super excited about, right? So in the future, one thing that people have been talking about is AI is gonna change how we interact with crypto, right? So instead of clicking through 5 different web pages to kind of find yield and then just do this very complicated gymnastic operations to actually start to kind of farm different yields. In the future, I do believe this is a good future that is you can just talk to an AI agent and say, hey, look, I have a $100 base chain, and I want to generate a 15% annualized yield. And my risk tolerance is that I can get exposure to ETH and maybe BNB token, but I want to limit the risk exposure such that if the price of ETH is reduced by 50%, my position should only be affected by 15%. Right, so here's a constraint. Go figure out whether this kind of a yield is possible or not. And this is a great future, but this kind of future really requires we to have verifiable AI inference, in the sense that when you talk to a black box, like a AI black box, how do you know that this particular AI model that is actually running your prompt or running your request is actually a powerful and a qualified model, right? So if we don't have verifiable inference, the only thing you can trust is brand. You can trust that ChatGPT maybe is like doing this, and some others doing this. But then that will basically end. That will kind of bring us to a future where like model is highly centralized, and then the scary version of this is like the entire humanity is controlled by a few companies, right? So like we don't want that, right? So like we need to make this kind of a model inference and computation decentralized enough. We need to be able to verify whoever is actually doing the inference workload is actually running the models that we agreed to, right? So like a qualified model. So how to do that again is using ZK, where you can essentially generate a commitment of the model. It's a cryptographic commitment to show that, okay, look, this is like the model like I'm gonna use. And with that commitment, it's essentially kind of you can think of it as a verified key. And with that commitment, you can basically verify and ask like the inference party to generate the proof for the inference to show that the actual correct high quality model is actually used, right? So you don't even need to know the detail of the model itself. You don't need to know the weights. You just need to know that this particular model is a good model, because along with commitment, you can generate a bunch of ZK proof showing that the already committed model passes a certain benchmark tests, right? So now you have this kind of a level of assurance to say that, okay, I can challenge inference result whenever I want to generate a ZK proof showing that this is actually coming from a validated model. But verifiable inference itself is not very easy, because like AI model itself like have a bunch of like float point numbers, and then these things are horrible for ZK in general, right? So like the straightforward the naive way to do this is to use things like quantization, which is like cutting the float point numbers to lower precision like integers, for example. But that will kind of cause the entire model to lose accuracy. Well, what we have discovered is that there is like this kind of a new research in the machine learning community, where you can essentially transform this kind of a float point based model to something called a ternary network, where in the model weights it only has 1, 0, and a -1. Okay, so you got a much larger model, like in terms of the number of parameters, in terms of the number of the size of the matrices, but at the same time you got much simpler weights in those matrices. So this will actually, the original motivation in the ML community is to run this model in low kind of a resource devices that cannot do a lot of float point computation as well. But it just so happens that these kind of models can be extremely ZK friendly as well, right? So like by doing this cross-layer design, by saying that, okay, you can transform this model into a ternary network, and on top of this ternary network, let's use a specialized GKR based proving system to prove this model inference process. You can actually get close to 100 times the performance gain comparing to directly run the model inference on the original model, right? So like the kind of the insight we want to drive in our work, is called SPA-ZK, is that we want to show that ZK ML or ZK verifiable AI inference is not only a ZK problem. It is a ZK plus ML problem. We need to do cross-stack optimization to not only just like do a ZK, gymnastics or like innovations, but also look at the ML model itself to make it like friendly to ZK in the first place. And this kind of cross-stack optimization is something that I think will enable the future of verifiable inference.
Awesome. You guys are building a ZK family or a
We are,
ZK-based
yes.
future.
We are. It's a pretty wide spread out like kind of a landscape, but I would say like our main focus right now is to push for adoption, right? So like our space really need the users. We need user growth. We need a better experience for the existing users. We need to grow this space.
Indeed.
Even though we're kind of doing infrastructure project, but we're very much application and user adoption minded.
Thanks for your effort. So, as we're wrapping up, I'm wondering, do you have any advice to give to the young and or new builders in the space based on the lessons you've learned in this industry for several years?
Yeah, well, I guess like given the current market condition, like the thing I want to say is don't leave. It's like you know, I mean, 5 years ago today, it's like the Ethereum crashed to $80.
Yes.
And we were all there. Like I still remember I chatting with you about this. Like I say, okay,
Mm.
like are we done here? Like it's like $80 now, and everything's like gone basically. Precisely 5 years from ago, right? So um, I think for new kind of developers and entrepreneurs in the space, right? So like this is a very very interesting space. It 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 has this kind of a swing between kind of a superficial looking or attention grabbing side of things and the idea, right? So the for different kind of builders, like especially technical oriented and technical born builders, uh, the uh, the past kind of a year or so like feels very much purely attention driven, and a lot of kind of new builders have expressed the frustration to me, personally. Say, okay, like I didn't know this is all this space is about, right? But I told them that, like, look, these kind of things just like is a clock of history, right? So it swings between the age of idea and to the age of attention, right? So it just so happens that you joined at the age of attention, and so as many other developers, so was me myself, right? So like we all joined towards the end of 2017 when it was like the old like swing to the age of attention, right? So but it's the age of idea that really kind of matters and pushes the space forward every time, right? For every cycle, and I think for better or worse, I do believe that we're not gonna stay in the age of attention forever. The age of idea is gonna come, and the age of idea drives the age of adoption. And we do, I do believe that this industry is worth staying because there are many many interesting, not only technical problems but also mechanism design, incentive problems, and also it's just generally a very fun place with a lot of good people as well, right? So like that's my, I guess, closing thoughts to some of the new builders in the space.
That's great. So, to people who are listening now, don't give up and don't leave. Cool. So, Michael, we have one last routine question, a small one for you. So, please name a project that you are bullish about.
I think kind of a one thing that I wouldn't say like there's a one specific project, but I think a lot of things that are happening in the background on the RWA and the stable token side of things. This is something that I like. The other day I attended a talk by SAP guys, like the old like SAP is kind of a and yeah, those guys, and they were talking about like how they are helping people to use stable token as a payment method across to cross border to do cross border payments, right? I think one thing that might actually come out like very good from kind of the more flexible regulatory environment is the flexibility to launch and compete with like with different teams launching different kind of RWA solutions and real world asset integrated into blockchain, right? So because like in the end of the day, we need to touch the real world, right? So like the last mile solution for the end users, and then kind of bring the assets from the real world to integrate into the new kind of financial rails that is much more efficient than the traditional ones. So, I do see there are a lot of projects recently popping up. It's RWA focused, not only just a stable token, but things like, credit-based lending that is also based on real-world assets. These things have risks, but they're good experiment and good endeavors nevertheless. And this is kind of the direction that I'm personally very excited about, and something that we have been also kind of working with like a lot of our partners to be announced as well.
Great. So with that, I think it's time to wrap up. So Michael, thank you so much for joining us and sharing from your wisdom. We learned a lot. We're going to share a few links in the show notes for anyone that wants to learn even more, and hope to host you again very soon and learn about recent developments. So yeah, thank you, Michael. Thank you, Queenie.
Thank you, Omer. Thank you, Queenie. It's great to be here.